The sun! The sun is an amazing thing. It helps plants grow. It helps keep you warm. Without the sun, we'd be in a lot of trouble. What is the sun?
I always thought they were balls of gas burning billions of miles away.
That's right. It is a big ball of gas burning millions of miles away. Up there. It's up there. Well, I promise. It's up there. It's behind the clouds. But anyway, God did something really, really amazing with the sun. But before we can talk about that, we need to talk about another concept of science. Here, come with me. Inertia. Inertia is the scientific term for how hard it is to start or stop an object. The smaller the object, the easier it is to stop. The bigger the object, the harder it is to stop. Inertia! 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 To show you inertia, we're going to give you an example. Thus, enter Tim. Now, Tim wants to work with me today because, well, frankly, he wants to throw things at me. So let's start with a really light object. If we have something really light, like, let's say, a blown-up balloon thing. Well, it's not that hard to stop. Pretty light, pretty easy. Its inertia is really small. Boop! Now, if you took something a little heavier, let's say a boot. A boot! Now, a boot has a lot more inertia. It's heavier, so it's harder to stop. Now, you know, we could even get heavier than this, like, let's say, a car or something, but who would be crazy enough to drive a car at me? That car had a lot of inertia. It was really heavy. Heavy objects are very hard to stop because they have a lot of inertia. Now, bigger things are even harder to stop, like, let's say, a house or a mountain or the Earth. The Earth would sure have a lot of inertia. It's really big. In fact, it equals about 6.5 septillion cars. How many cars is that? That's like a lot of cars. That's more than 1 million or 1 billion or 1 trillion cars. It's huge. That many cars wouldn't even fit on the Earth. So that's a lot of inertia. What would it take to stop the Earth from turning? A lot. I mean, maybe even another planet to stop the Earth. The Earth has a lot of inertia. This chair, when it's spinning, has inertia. It's not that hard to stop, though, because it's pretty light. Put something heavy in it, though, like, Tim, and it gets heavier. So when it spins, it has more inertia, or it's harder to stop. Why do I talk about spinning and inertia? Well, because we're going to get back to the sun. When we think of the sun, we usually think about it moving across our sky, rising in the east and setting in the west. But I'm here to tell you that the sun doesn't actually move. What is actually moving is the Earth. Spinning. Inertia. Let me demonstrate. Notice that this sun will not move this entire time. The only thing moving is going to be Tim, the Earth, spinning in the chair. Are you ready? Here we go. As Tim begins to spin, it starts looking like everything around him is moving. Now, if you watch the star come up and pass, you will see that it looks like it passes across the sky. Here we come again. Did it look like the star moved? Yes, it looks like the star is moving from one side to the other, but in reality, it's staying still. What is moving? Tim is moving. The Earth is moving. We are spinning. Now, if we were spinning like this, and Tim was the Earth, remember how heavy the Earth was? What would it take to stop him? Well, in this demonstration, all it would take was me stopping the chair. As you noticed, it didn't take much to stop Tim. I mean, he's just not that heavy. Sorry, Tim. But if this had been the Earth, it would have been really, really hard. Remember, the Earth has a lot of inertia, or it's really, really big. So, to stop it would be very amazing. It would take almost another planet to make it stop spinning. So, there's one question I need to ask you. If the sun moving across the sky is because the Earth is spinning, how do we get the sun to stay still in the sky?